All right. Hello, everyone. Hang on while I zoom in here. Sorry about this. This is just the solutions to the assignment on section 4.3. Should be pretty quick. It's just all going to be me talking, actually. I could write it down, but why bother? So problem number 21 we started with, it says a psychologist wants to compare children from first, third, and fifth grades to determine the relationship between grade level and how quickly they can solve a word puzzle. Would this be an observational experimental study? It might not be a great one, but it's definitely an experimental study. And the main thing that distinguishes an experimental study from an observational study is the fact that you are doing something to someone. So if you go into these grades, set it up, make them solve a word puzzle, you're doing some sort of an experiment. Okay, 22. The buttercups, some grow in bright sunny fields, others grow in woods where it's both darker and damper. A plant ecologist wanted to know whether buttercups in one habitat had adapted in a way that made them less successful in the other one. First study, he dug up 10 plants from each habitat. 5 out of each 10 chosen at random were planted in the habitat they came from. The remaining 5 were planted in the other habitat. At the end of the study, he compared the size of the plants. Why did he bother to dig up the plants? And is it an observational study experiment? It's definitely an experiment, right? Because they did something to someone. They did a control group. They had a treatment, per se. And the reason they dug them up and put them right back in was to make sure they were controlling for lurking variables. And I often think you want to do an experiment, right? So if we dug up these 5 plants and planted them in other habitat and they died, and we said, hey, it's because of the other habitat, but maybe it was just because we yanked them out of the ground, right? So we yank them out of the ground, put them back in the same habitat. If they grow back in that habitat, but not in the other one, then we know there's an issue there. Okay. 25. Does living in colder climate make you healthier? To study the effects of climate on health, imagine comparing the death rates in 2 states that have very different climates, Florida and Alaska. And they tell you what the death rate means there. And then it says, why is death rate used as the response variable instead of number of deaths? So this is kind of my pet peeve. I've been seeing this a lot in the newspapers lately with the COVID-19 stuff where they say like, hey, California leads the country in deaths. Well, yeah, we have the most people, right? So that's kind of a silly stat. So we always want to use percents instead of raw numbers just because there's a different amount of people, a lot more people in Alaska than there are in Florida. And then it says, if you're going to study the climate, do you really want to look at death rate? Maybe there's something better. And is there a lurking variable here, in essence, is what they're asking. And again, you would have to know this, but Florida is a pretty popular retirement place. Nice weather, warm weather all year round. So a lot of people retire to Florida. And so if you check the death rate of Florida versus Alaska, you might have a higher death rate just because you have a different type of population, much older population there. Okay. And then 26. Suppose you have 50 subjects and you want to assign 25 to treatment A and 25 to treatment B. You flip a coin. If it's heads, the first subject goes into treatment A. If it's tails, the first subject goes into B. And you continue doing this until you have 25 in one of the groups, and then the rest go in the other group. Does this method randomly divide the 50 subjects into 2 treatment groups? Explain. I don't like this question because I don't think they're asking what they really think they're asking. If they're just using the terminology, does it randomly divide? Well, yes, it does. It uses randomness. That's what it means to randomly divide. Now, is it a simple random sample? No. Not every group has the same chance of being picked together. The biggest issue, which maybe you referred to anyway, thinking it wasn't random, and maybe it's the word, it doesn't even say equally random, right? So anyway, the people at the end are much more likely to go into or wind up together, right? So unless it goes every other one until you get to the 48th person and then you have 2 left and 1 in each group, it's much more likely that those last 2 guys are going to wind up in the same group, right? Like if you get an overload of heads, even just 1 extra head, then all those heads or all the leftover tails at the end will wind up in the same group. So it does randomly divide it, but just, it's awful, but not really a wrong. I don't think that would be wrong to do it that way, just so you know. It's maybe not perfect. It's not a simple random sample, but often in the math world, we're looking to shortcut the process a little bit, but still make it like what we would call legal. So kind of be okay on that one. So that's it for 4.3. If you made it this far, Chapter 4 tests coming now. We'll talk about on Friday. Have fun.